Hello students, today we are going to further our understanding of chemistry by discussing properties of matter, specifically physical properties of matter and chemical properties of matter, and reviewing chemical and physical changes. So let's go ahead and get started. We need to first go ahead and define matter, and we know that matter is anything that has mass and volume, taking up space and a measure of the amount of material in a substance. And now, of course, we're a little bit more knowledgeable, and we understand that matter is made up of atoms. So that's our focus. We need to travel down memory lane for just a bit into describing matter and how you guys have done that thus far. In your 5th grade days, you studied mixtures, and you then took that to 6th grade and understanding substances. Specifically, you worked with elements and distinguished elements and compounds and molecules. And then with elements, guys, you really talked about physical properties of elements. And you took that to the periodic table. And of course, now in 8th grade, we're going to take elements even further, break them down further to the smallest building blocks of matter, which is the atom. And not only are we going to be looking at physical properties of the atom, but more importantly, the chemical properties of the atom. And the chemical behavior of the atom is what chemistry is all about. The periodic table needs to be mentioned here, the periodic table of elements, a great tool of organization. It tells us all about the physical and chemical properties of matter. You guys have learned about the physical properties of metals and nonmetals and metalloids. In 8th grade, though, we're looking at the periodic table in terms of chemical properties, and it gives us a wealth of information on how atoms and elements will behave and react with other atoms. And so in 8th grade, we're going to be looking at the periodic table and reactivity. You'll do more with the periodic table in your high school classes. To describe matter, guys, we tend to use the word property, which is just adjectives and descriptive words. So we have physical properties and we have chemical properties. And physical properties are those that can be observed or measured, and you do not change the material's composition. You still have the same substance with the same identity. Some examples of those physical properties would be to describe the color or the boiling point or the hardness or the density of matter. Whereas chemical properties are a property that can only really be observed when the material is being changed, like during a chemical reaction, or during a chemical change. So a chemical property is a little bit more difficult to understand. It's really the ability of matter or elements or atoms to behave in a certain way when exposed to certain other conditions. So the ability to burn or to decompose or to react with other substances are considered to be chemical properties. In this data table, this is all about physical properties. Again, we're not changing the substance. We're just observing it. We're measuring it. Classic examples would be, boiling point, boiling point, or the density would be a great tool for describing matter. Chemical properties here we can see are the properties of copper. So let's look at copper for just a minute. And we've got knowledge of copper because we have pennies in our lives. Maybe we don't like them too much, or we do like them. But we know that they have a distinctive color and a luster, and they can be shaped into wires, good conductors. Those are all physical properties of copper. But copper also has chemical properties, and those chemical properties are its ability or likelihood to react with other substances. And specifically, copper can react with moisture in the air and can form a substance called copper carbonate. And it's entirely different than what we know copper to be. It's actually a green substance with a different density. And that's actually an example of our Statue of Liberty and why our Statue of Liberty is green, because it's experiencing a chemical property that's happening to the copper where it's going through a chemical change. Physical changes then are those types of changes where only the physical appearance has been changed. You still have the same substance. The properties remain the same. Cutting up a sheet of paper, breaking glass, a change from a liquid to a gas. Those are all physical changes. Chemical changes, though, are those where you have something new that's formed, and that's the key to this. There's a new substance that's formed. It's commonly referred to as a chemical reaction. new substances with entirely new physical and chemical properties. So examples of that would be rusting or flammability or decomposition. And we know that there's evidences of chemical changes that helps us to identify that a change is taking place or is taking place. The production of a gas or a temperature change or a precipitate solid that was formed. If you look at these apples, guys, they are very pretty. They have physical properties that are green and round and smooth. If we were to look at them in a physical changing example, we could cut them into wedge shapes. We could juice them and get their liquid. I still have an apple though, even though it's in liquid form or I've changed the shape, it's still the same substance, the same material. So that's an example of a physical change. Whereas these apples also can have chemical properties, and one of them is the apple's ability to react with oxygen, and that's called oxidation. And so over time, guys, the apple then would chemically change into something new as it began to decay and to rot. It would form a brown substance, which is a whole new substance that is no longer an apple. And so that is a definite example of a chemical change. An entirely new substance is formed.